So if you're watching this video, you're probably going to have to fast forward through some of today's activities because there's a little group work going on. And so when you don't see anything happening to the screen, you can fast forward. All right, I do want you to be able to hear us go over the homework. Now, a couple things we talked about, the teachers talked about yesterday at lunch. Things that we expect you to know. And I expected you to know them, but I didn't give you a heads up about it. So let me give you the heads up. I expect you to know your perfect squares through 400. So, you should know, wait. If I said 225, you should go, oh, that's 15 squared. It should automatically ring a bell. If I said 324, you should know that that is 18 squared. Right? I mean, it should be automatic. That's the first thing you should think about. So, you memorized your squares.
Actually,
long ago. Yes, those you're pretty familiar with. Now, we expect you to know your perfect cubes. 1 cubed to 6 cubed. 1 cube doesn't really help you, so let's start with 2 cubed. 2 cubed is 8. 3 cubed is 27. 4 cubed is 5 cubed is 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. 10 cubed is 1,000. Okay, when I taught middle school, we had to memorize the squares 1 to 25 and the cubes 1 to 10. So I know they don't make you memorize all the way to 25. I think now you do your squares 1 to 20, right? Okay, you did to 25?
Never.
Excellent. It's time.
We did the squares.
Okay, and the other thing we would like you to maybe not memorize, but for it to come really quickly to you, is your powers of 2. Now, 2 to the first 2. 2 squared 4. 2 cubed 8. 2 to the fourth, 16. So when you see 16, you're thinking 4 squared or 2 to the 4. 32 is 2 to the fifth. So when you see 32, it should hit you that that is a power of 2, and you should be able to figure it out quickly. When you see 64, or 64 is a factor of something, you should think power of 2, and it should hit you quickly that that is 2 to the 6th. Okay, and then 3 squared is 9, 3 cubed is 27, 3 to the fourth would be the same as 9 squared, so it would be 81. 3 to the fifth wouldn't be hard then, because 3 times 81 is 243, right? Not hard. Good. All right. I think that's really pretty much what we talked about. So now I want you to ask questions. And before you start asking questions, please don't go, I didn't understand 4 through 52. Multiples 4. Please don't say that. Definitely don't say it that way. I have to make fun of you. All right. Okay, Jocelyn. 12. Excellent. Okay, so let's take a look at 12. We went over that one last period too. That was a good one. Okay, the top looks really worked out pretty for us because it's a cubed root of x to the 15. And the way we talked about it was, remember that a cubed root is the same as the 1/3 power. So I'm basically taking the 15 and dividing it by 3. And it divides in there nicely. 3 goes into 15 perfectly, 5 times. So that's to the 5th. Does that make sense to everyone in the room? I hope so. If it doesn't, watch yesterday's video again, and again, and again, until it does. Okay, good. Now, the denominator is a little tricky. So here we get the numerator, x to the 5th, but we have the cubed root of 7 in the denominator, and we can't have a radical in the denominator. Now, it was so simple. If this were just x to the 5th over the square root of 7, we would just multiply it by square root of 7 over square root of 7. Because the square root of 7 times the square root of 7 is just the square root of 49, which is 7. So that was really simple for us. But this isn't a square root. This is a cubed root. So to take a cubed root, I need to have something to the 3rd power under the root, don't I? Well, let's write it out over here. Because it might be easier if you saw it this way. There is 7 to the 1st here. So to be able to take a cubed root of something, how many more 7s do I need?
2 more.
2 more. So I need 7 squared. Because when you multiply, you add the exponent. And what is the value of 7 squared? so that's really the same thing as the cubed root of 49. So now I get the cubed root in the denominator, the cubed root of 7 cubed. What happens to the root and the cube? They cancel, and that's where the 7 comes from. And then in the numerator, I have x to the 5th times the cubed root of 49. Does that make more sense for number 12? Nope? Okay, we'll see some more in a minute. Well, I'll do some more. Okay, what else? Okay.
The understood 2 in the denominator, like on number 32, for example.
32. Let's take a look at 32. Okay. Now, when we had a cubed root, there's a little 3 right here. And the cubed root is the same as the 1/3 power. We just said that. If it was a 4th root, where's 1? I don't see 1. If it's a 4th root, there would be a little 4 right there. And a 4th root is the same as raising something to the 1/4 power. Well, this is just a square root. And a square root is the same as what power?
2.
The 1/2 power. Taking the square root of something is the same as raising it to the 1/2 power. So here, this square root of y to the 5th could be written as y to the 1/2 raised to the 5th. Power to a power we multiply, and this is what we get. Now remember our shortcut yesterday, we talked about this is the root, this is the power. So if I gave you the 7th root of x to the 5th, this is my root, this is my power. That's x to the 5/7. So your root always is your denominator, the power is the numerator. But this is why, because when we multiply them, we get our root times our power, and that gives us that. Okay? All right, what else? Okay?
There's one. Okay, it was number 40. I don't understand how you got 7 over 2.
Okay. When you multiply like bases, n to the a times n to the b. When we multiply like bases, yesterday we talked about you add your exponents. So I'm multiplying like bases, so I have to add the exponents. 1/2 plus 3 is 3.5. Do we ever have a mixed number? No, we don't. So you just change that to 7/2.
Number 44.
44. All right, this is division of like bases. When you have division, what can you do with the exponents? Subtract them. So what is 5/4? Take away 1/4. 4/4. And 4/4 is just the same as first power. Yes, Connor?
By like basis, what do you mean like they both have to be 25, so
Yes.
they just have to have the same variable?
They have to have the same base. The base of this one is 25 and the base of this one. Like this one, the base is x and the base is x. They have to be identical.
What if that was like 12x and like 4x for the other one? Could you not multiply them?
You can, because it would all be multiplication. Addition and subtraction, different rules, but multiplication we're good. Yes, ma'am.
And so if there's a power under a radical, is it treated the same in this if it's outside the parentheses?
Like the cubed root of x squared, we could think of as x squared to the 1/3, right? So x to the 2/3. And let's do the cubed root of x squared. This is like x to the 1/3 squared. And when we multiply these, do you see we get x to the 2/3? Are they equivalent?
Yes.
Yes. Good question. Yes, sir. Yes, sir.
Just like, if you didn't, what I should say in general, does it matter, like, if you had
And then just combine
the cube root of 8 squared, would it matter if you did the cube root of 8 and then square it, or if you squared it and then,
Okay, so Brian's question was, 4. What's the cubed root of 64? 4. Did I get the same thing? Sure. But I just like dealing with smaller quantities whenever possible. And so I will take that route. I will take the root before I do a power. Okay? All right. Let's take a look at the rest of them. See if you have questions.
Um, 52.
Okay. We'll do 52. I don't know who supplements.
No.
Can't even get to it. Oh, double whammy. They busted me.
Should I answer this one?
No, I'm good. Brr. Hello. Yes.
I think she may have showed 2 different ways to get it.
Oh, that's not good.
What?
That is the school number.
Call them.
That means it's the middle school.
Important.
I'm like, wait a second. That's the Stars Mill extension. Oh.
Grades are done.
6.
So your daughter's calling you?
Already in trouble.
I'm sorry. Do your parents have you have to be bleeding, you have to be puking, or you have to have a really high fever for me to come get you real?
Yes.
Yeah, I do too. The I'm not feeling good doesn't work. Oh well.
My parents don't have that one.
Yeah.
I call my mom and I'm like, my stomach hurts. And she's like, I'm coming. And she's like, I'm already here. And then it's like, oh.
Wow. We have you have to be, and not
I
just
don't-
like
I don't
bleeding,
like
like
blood
bleeding
as well.
profusely. Something major has to have happened.
God, you need to get stitches.
Yeah, yeah.
You need to get surgery.
Alright, so we need to go over 52. Sorry to those of you that are watching the video, we have a little drop. Alright, so we have x to the 1/3 divided by the cube root of x squared. Alright, so we have a rational exponent and we have a radical. It's really easiest to deal with one form or the other, but when we have both, it's a little confusing. So you're either going to want to convert both of them to the rational exponents or both of them to the radical, and it doesn't matter, whichever one you're more comfortable with. So here it's converted both to the rational exponent, so where we do this subtraction, z to the 1/3 minus z to the 2/3, we get z to the negative 1/3. What does a negative exponent mean? It moves to the denominator. It means reciprocal. So the z to the 1/3 is going to go to the denominator. So this is what we get when we write this without the rational exponent. We get 1 over the cubed root of z. Now, if I had right here just said, all right, this is cubed root, this is cubed root, put that in the wrong spot, cubed root of z over cubed root of z squared. Since they're both cubed root, do you see I could write it as the cubed root of z divided by z squared? Yeah. So this cancels with one of these. So it's the cubed root of 1 over the cubed root of z, which is 1 over the cubed root of z. Is that the same thing? Yes, it is. Okay. Now this is a good problem to ask about, because it's just like that other one.
That's where I stopped.
That's where you stop. Okay.
I don't
So,
know one.
all right. So let's talk about how we alleviate this problem. 1 over the cubed root of z. I cannot have a radical. And to get rid of the radical, I have to have something that I can take a cubed root of.
Z squared.
Right now I have a z to the first power. I need to multiply that times a z squared to make it z cubed.
Why?
Right now I have it because I have to take the cubed root.
You're not allowed to have a radical in bottom.
Brian is correct.
Why not?
It's a rule. It's a radical rule. So we have to multiply by the cubed root of z squared over the cubed root of z squared. And that will give us the cubed root of z cubed over the cubed root of z squared. And the cubed root of z cubed is just z.
I'm so confused. Why'd you write it twice? Oh wait, you didn't. Why is it what?
Okay, I had to multiply by this to get this out of the denominator.
Okay. I still don't understand that though.
How about you come to Aagaa today? And we can do it, just me and you. I bet it won't take 5 minutes when it's just me and you. Alright, any other questions about these? Okay. Most of your homework looked good. Some of you look like you wrote down answers. And sometimes just random answers. I gave you your 2 points completion. I did. But I did every day. It's 2 points for completion. But I'm a little concerned about what's going to happen on our test Wednesday.
I'm gonna forget my
Alright, so those of you that just wrote down some stuff on a piece of paper to get your 2 points, make sure tonight we have understanding. And if you don't, my YouTube has some excellent videos that you can watch from yesterday.
I tried my best.
Okay, real quick, before we get into today's lesson, I want to make sure you guys know this stuff. This is old stuff. You don't have to write this down. If you want it, you can print it off my website later. Do we all know that natural numbers are just our counting numbers? Like 1, 2, 3, 4, blah, 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 blah. Yeah? Okay, do we all know that whole numbers take our counting numbers and put 0 at the front of them? And that integers are just the whole numbers and their opposites. And rational numbers are the numbers that can be written as a fraction. Like 1.25 could be written as 5/4. Negative 4 is negative 8/2. So anything we can write as a fraction. Irrational numbers are those non-terminating, non-repeating decimals. Like pi. Square roots we don't know the square root of. Like square root of 2, square root of 7, square root of 11. E is another non-terminating, non-repeating decimal. And both of these make up our real numbers. And then we just learned some weird numbers, didn't we? What were those? Imaginary numbers. So those are square roots of negative numbers. And the imaginary numbers fall into our complex. And wouldn't complex contain all of the above? Because complex contains the imaginary, which I didn't write down, but we did talk about. Contains the imaginary part. It also contains the real part. And the real contains all of the above. So, complex is a pretty big heading, isn't it? It contains a lot of things. Alright, so today, first thing we're going to do is you're going to answer. Whoa, 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 whoa! You're going to answer these questions. It's on a PowerPoint. That's what I meant to do. There we go. That's what I meant to do. Here we go.
You should look this small, this setting. Close your eyes.
Okay, so today, I know y'all memorized all the standards, but these are the standards we're covering today. NRN 3, AAPR1, and we're going to do the MP2.
There's supposed to get on to the MP3.
What the heck?
Yes, I'll let you know when we get to MP3.
Oh, yeah.
Okay, number 1, these are the questions I want you to talk about in little groups of 2 or 4. 2 to 4. Is the sum or a product of rational numbers rational? That's the first one. Is the sum of a rational number and an irrational number irrational? And is the product of a non-zero rational and irrational. Irrational. Okay, a number that's not zero. When it says non-zero, it means anything other than zero.
Are rational numbers just normal numbers? Pretty much. And irrational are like negative.
Two is yes.
Huh?
Square root
It's like anything that can't be written like 0.25.
I would say yeah.
Yes, yes.
Okay, while y'all are doing that, I'm going to take care of the you're not making
Some is the same as two. Oh, wait, no, so that'd be like 3 times. Yes. I think they're called yes. Because they're
I'm like getting the heavy waves of this stuff, and we're just like tracking each other. Mary Kate.
Yes. A rational number and an irrational number. If you're rational, so like 2.5 times 3.
I guess 3 is just a pick.
Okay, zoom in on the I want to zoom in on
Grace, watch 13 going on 30 tonight. I will. Drew. Did you recommend that? Did you recommend that movie? I haven't seen it since I was like 12 years old, but it was pretty good when I was 12. It's sort of the
Grace.
Grace. It just kind of shows how stupid someone is trying to skip their college, high school, and
What? It's like in the movie.
Give me my phone.
Oh, come on. You know what I told you?
Expect to be violating.
No, I'm talking about the you watch it with your mom.
No. Alright, so like, it would be like summer and I'd get home from football and I'd just go to your hand and I'd be like, what movie have I not seen? I watched everything on HBO and that was me. First 3 days of school, I did that like going on senior school cross. I would just be like sitting there and I'd be like, what did you get from me?
She is not
And then
dying,
they would be like,
bleeding, puking, or
Wait, who?
my daughter.
What happened? What happened? Why'd you go?
Where you go out?
it's got my phone number and then
I don't feel
mom.
well.
I'm in the back, it says we.
Alright, so we should have wrapped this up. Okay, so, what did you decide on this? You decided yes. And was that because I accidentally left all the answers up?
No.
Okay, it's because you really thought about it. Excellent. Okay, so if we think about this, this made no sense to Does that represent any fraction I choose to make it? Yeah. Okay, so if I'm adding that to another fraction, represent any other fraction I choose to make it, is this possible? Yeah, it is. This becomes A times D plus B times C over B times D. Did I make another fraction?
Wait, how did it happen?
I got a common denominator. What's the common denominator for B and D? BD. And doesn't A have to be multiplied times a D?
Why?
I understand.
Okay. 3 halves plus 1/5. What is the common denominator? 2 times 5, which is 10. The 3 gets multiplied times the 5. And the 1 gets multiplied times the 2. Isn't that how? Yes.
I got it.
So much easier than the way I always
Okay. Good. Alright, so yes. Now let's do product. So A over B.
Wait, wouldn't that
times
be irrational
C.
numbers though?
No. Where did
Fractions are irrational.
No, fractions are rational.
That's what
how
you
we
just
I said a
You said
anything that
decimals
can be.
and fractions
No.
are irrational.
No, I said some decimals are irrational, some are irrational.
Okay, what and the ones that are
1 to 5 is
irrational are the
rational.
decimals that
What's
represent.
irrational?
Okay, hold on. Look right here.
Alright.
The decimal that represents the square root of 2. 1.41, a whole bunch of stuff. Right?
That's irrational.
That's rational.
So if it's like it ends on like at the 100th, 1,000,
It's rational. Just like 1.25 can be written as
how far is it
5.
allowed to go?
If it ends, it's rational.
As long as it ends,
Wherever it ends. If it ends, it's rational. Okay. Is the sum of a rational number and an irrational number irrational? Yes. Because we can't get rid of the irrational part, can we? So it stays irrational. It just takes that irrational number and shifts it up or down. It's still irrational. Yes.
what is an E?
E is like pi. You'll learn E. Okay, it's the product of a non-zero. So this means anything but 0, rational number, and an irrational number, irrational. Yes, it's still going to be irrational. Like if we took the square root of 2 and we multiplied it by any rational number, 3, is it irrational? Yes. If we multiplied it by 0.25, is it still irrational? Yes. I'm not getting rid of the irrational part, am I? So it's still irrational. Okay, so we're going to take these ideas, and I'm going to leave this up here because this might be helpful for some of you. We're going to take these ideas and apply it to closure. Now, the definition for how we determine closure is on here. A set, and we're going to look at the sets that are on here. A set is closed under an operation if and only if the operation on 2 elements of the set produces another element of the set. Okay. If an element outside the set is produced, then the operation is not closed. So, let's do an example together of this. So we're going to try to decide if the set of natural numbers is closed under addition. What this says is if I pick any 2 elements of the set, any 2, pick a natural number. You picked 4, which one do you want? 8. Is 4 plus 8, is the result also a natural number?
Yes.
Is there any way I can pick any 2, add them together, and get something that is not a natural number? Then the set of natural numbers is closed under addition. Because we can add any 2 things that are in that set, and we still get a result that also is in that set. It is closed under addition. Does that make sense?
Yes. Yes.
Okay, your job as groups of 2, 3, 4 is to look at all of these and to decide if they are closed or not. If you decide they're closed, just write either closed or yes. If you decide they are not closed, then I want a counter example. I want something that shows it is wrong. Like, let's look at this. Natural numbers subtraction is not closed. Because if we took your same 2 numbers, 4 and 8. 4 minus 8 is negative 4. Is negative 4 a natural number? No.
Now you're speaking my language.
So, if it's yes, just write yes. If it's no, give a counter example. It is not closed.
Can I just write a little bit?
No. Slightly different meaning. Okay, if you are watching this video, what we are doing is completing this chart. We will come back to the answers in just a moment. Just look at the answers that are posted on my notes on the website.